Hello everyone, welcome to another video of Advanced Mathematics of class 9, and today we are going to continue with chapter 7. We had completed theorem 1 and 2. Today we are going to do theorem number 3. So what does the theorem 3 say and how do we prove it? We are going to look into it, so make sure you watch the video. So what does the theorem 3 say? According to the theorem 3, if there is a triangle, then the perpendiculars drawn from the vertex to their opposite sides, means if A, B and C are the three vertices, if I draw a perpendicular from A to BC, perpendicular drawn from the vertex to the opposite side from all the three vertices. So if I draw another perpendicular and I draw these three perpendiculars, if these are the perpendiculars, then they will meet at a common point, means they are concurrent. So this P is the concurrent point. We have to, means this is the theorem and we have to prove it. That again, let me repeat if you have not understood. ABC is a triangle, A, B and C are the vertices. If we draw perpendiculars from the vertex to the opposite side, from the vertex to the opposite side and from the vertex to the opposite side, these three perpendiculars will meet at a common point, means they are concurrent. We have to prove this. This is theorem number 3. So let us see how do we prove this. So for this, we are going to have a different type of diagram this time. So let us suppose we take a triangle. Suppose this is our triangle ABC, okay, and we draw the perpendiculars as I have done here now. So I will draw one perpendicular from A, one perpendicular from B and one perpendicular from C. Okay, so these are all perpendiculars. Okay, so I have to prove that they are concurrent, that is they meet at a common point. Let's give the name of the point O. Okay, now what we do, we make some constructions. So what are the constructions? We will draw three lines passing through A, B and C, and they will be like this. We will draw a line passing through A that will be parallel to BC. So we will draw something like this, that is parallel to BC. Then we will draw another line which will be parallel to AC passing through B. So we will draw something like this. This line must be parallel to AC, and another line from here passing through C which will be parallel to AB. So we are drawing three lines. This line will be parallel to AC, this will be parallel to BC, and this line will be parallel to AB. Okay, so these are all parallel lines. Now this is what we have to prove, as I said. So what we will do is we will consider that, let me give another name. Suppose it is D, E, F, and this, let it be X, Y and Z. Okay, these are the namings I have given. Now let us suppose, what we will assume, that CF is perpendicular to AB, BE is perpendicular to AC, and they are meeting at point O. What we will do is, we have drawn AO and extended it to D. We are not considering AD as the perpendicular. Okay, what we are only considering is ABC is the triangle, BE and CF are the perpendiculars. What we have done is, we have joined these 2 points AO and extended it to D. Okay, we are not assuming this to be perpendicular. So as we are not assuming this to be perpendicular, if we can prove that AD is also perpendicular to BC, that means these are all three perpendiculars and they are meeting at O. If you have understood, this is the same way we have proven theorem 1 and theorem 2. We take into consideration any two and we prove that the third one is also following their criteria. So these things we have to write for the theorem 3. When you prove it, you are going to assume that let ABC be the triangle where BE is perpendicular to AC and CF is perpendicular to AB, and they meet at O. Okay, they are meeting at O. AO is joined and extended to D. So this is AD is not a perpendicular. We have not considered it yet. So that means we have to prove. So we have to prove that AD is perpendicular to BC, because if we can prove this, then we can prove theorem 3. Now what are the constructions? We have XY parallel to AB. Then we have XZ parallel to AC, and we have ZY parallel to BC. That is what we have done. Now we will start the proof. So what we have in the proof, if you look carefully, as I have said, ZY is parallel to BC, that means obviously ZA and BC are parallel. Okay, and as ZX and AC are also parallel, that means ZB and AC is also parallel. So as the opposite sides are parallel, so if you consider BCAZ, this thing, this becomes a parallelogram, right? This one is parallel to this one is parallel to this one, so this structure becomes a parallelogram. In the same way, BCYA also becomes a parallelogram. BC is parallel to AY, AB is parallel to YC, so BCYA is a parallelogram. So this is what we are going to write, that since AZ is parallel to BC and ZB is parallel to AC, therefore BCAZ is a parallelogram. Similarly, BCYA is also a parallelogram. So if they are the parallelograms, in parallelograms we have opposite sides are equal. So we must have, as BCAZ is parallelogram, so therefore as this is a parallelogram, ZA and BC will be equal. So therefore ZA is equal to BC, and from this triangle from this parallelogram, BC will be parallel to or equal to AY. So we will write, and BC is equal to AY. Now if you look into these two, ZA is equal to BC, BC is equal to AY. That means what? ZA and AY will be equal because BC is common. So hence ZA is equal to AY. Now if ZA and AY are equal, that means A is the midpoint of ZY, right? So we can write that therefore A is the midpoint of AY. I mean not AY, ZY. A is the midpoint of ZY. Now look, similarly we can show, as I have shown A is the midpoint of ZY, I can show that B is the midpoint of ZX, C is the midpoint of XY, because these are all symmetrical diagrams. So we can also show similarly we can show B is the midpoint of XZ and C is the midpoint of XY. Done? I hope it is clear till now. So we have proven that these three are the midpoints of these three lines. Let me erase this part. So what can we say? Now why we have done this? What is the use? Since, okay, let's take into consider this part, okay? BX and BZ are equal, B is the midpoint. Now we have said that BE is perpendicular, we have taken it into consideration in our let part. So BE is perpendicular to AC, but we have also said that AC and XZ are parallel, okay? AC is parallel according to our construction. So this line is parallel to this line and this is perpendicular to this. Now if I say that these two lines are parallel and this line is perpendicular, obviously this is also perpendicular, as these are parallel lines. A line drawn perpendicular to one of them will also be perpendicular to the other. That means that BE is perpendicular to AC, alright, but BE also becomes perpendicular to ZX. Now since BE is perpendicular to AC and AC, I mean not perpendicular to AC and AC is parallel to ZX, therefore BE is also perpendicular to XZ or ZX, whichever you want to write. So that means this line is also perpendicular to this line. That means what? After so much, that means what? That means that it means that B is the midpoint of ZX and also the perpendicular. So it is the perpendicular bisector. Remember theorem 1, perpendicular bisector. So BE will be the perpendicular bisector of ZX. Therefore BE is the perpendicular bisector of ZX. Similarly, we can also show CF is the perpendicular bisector of XY. Similarly, CF is the perpendicular bisector of XY. Okay. Now what have we learned from theorem 1? In theorem 1 we have seen that the perpendicular bisectors of the triangles are concurrent, right? They are concurrent, they meet at the same point. Now we have shown that BE is perpendicular bisector of this, CF is perpendicular bisector of this, and they meet at O, right? Now we have also shown that AD is also meeting at O, right? AD is meeting at O, right? That means what? AD is the perpendicular bisector of ZY, because they must be concurrent. As AD is meeting at O and these are the perpendicular bisectors of these two lines or sides of the triangles, that means A must also be the perpendicular bisector of ZY if we compare to these two, right? So therefore AD must be the perpendicular bisector of ZY, right? A is the perpendicular bisector of ZY. Now we have said that ZY is parallel to BC in our construction. As ZY is parallel to BC and AD is perpendicular to ZY, that means AD must be perpendicular to BC. So therefore, since ZY is parallel to BC and AD is perpendicular to ZY, therefore AD is perpendicular to BC. This is what we had to prove. Okay, so finally we can say that the perpendiculars drawn from the vertex to their opposite sides are concurrent. So this is our required proof. In two proof we will see I had to prove that AD is perpendicular to BC, so hence proved. So we have proved our theorem 3. Now what is this point called? A triangle in which we have drawn three perpendiculars from the three vertices and they meet at the common point. This point is called the orthocenter. Okay, orthocenter. So that is theorem 3. In our next video we will move into theorem 4 where we talk about the medians. So hope you understood this. Ask your queries either in the app or in the WhatsApp group. I will be there to help you out. So thank you everyone for watching, and until next time, cheers.